Welcome to another tutorial on vectors. In this tutorial, we're going to look at a question I left you guys with in the previous. I hope you have time to go through it. So let's quickly look at what they want us to do. So being told that we have a particle that undergoes 3 successive displacements in a plane as follows: 4 meters southwest, 5 meters east, 6 meters in the direction 60 degrees north of east. Then choose the y-axis pointing north and the x-axis pointing east. Then find part 1, the components of each displacement. Part 2, the components of the resultant displacement. Part 3, the magnitude and direction of the resultant displacement. Then part 4, graphically show the approximate displacement of the particle. So when you look at this question, it's like what they want us to find really, it's basically everything that we do when we're finding the resultant of 3 vectors. Because to find the resultant of 3 vectors, what we have to do is we have to find the components of each vector, then we have to add the respective components to get the component of the resultant. After getting the component of the resultant, we use those 2 components of the resultant to get the magnitude of the resultant and the direction of the resultant. Then again, using the same 2 components of the resultant, we can also graphically show the displacement of the resultant vector. So this is just a breakdown of the step-by-step approach that we take whenever we want to find the resultant of 3 vectors in this case. Okay, let's quickly go through how we are supposed to work this question out. Okay, so in the first part, the first thing that we have to do here is first understand the presentation and the use of southwest, east, north of east. Just trying to understand what that language means. So before we even work out this, let's just quickly go through what that language means. So if a question says 4 meters south of west, not south of west, let's just say they say southwest. So here notice that they are just plainly stating the pose without even saying anything. So without giving an angle. So it can be southwest, it can be maybe northeast, or northwest, or southeast, such stuff, such comments. Now, what do these mean in terms of direction of the vector? Because it's like they're using the pose to specify the direction of this vector. Well, very easy. If we present this, because the question says we take the north to be the y-axis to be the north in I think it's pointed out here, the y-axis pointing north and the x-axis pointing east. So it's like this one, this is going to be where the north is. Of course, this is the y-axis. And then this is the east. That's where the x-axis is going to be. Now, of course, we know that west is going to be here and south is going to be down here. Now, when a statement is say southwest, what that means is the direction of this vector is exactly midway between the south and the west. In this case, southwest is going to be exactly midway between them. So in other words, the angle we're making here is going to be 45 degrees. So if they just say southwest, they mean the vector is exactly midway between the south pole and the west pole. Okay, now how about, of course, if it was northeast, we have to look at, okay, this is the north, this is the east here. So exactly midway between the north and the east. We're talking about something like this. And the angle here is going to be 45 degrees. Okay, now this is what they mean when they use a term like southwest, northeast, or northwest, and so on. Now, let's look at the other terms. How about if they use something like, if they just say east, like in the next statement, they're just saying we have, that's 5 meters east, or maybe they say 5 meters north, without just using one pole. Well, it is similar to what we had when the question says 5 meters along the positive x, or 5 meters along the negative x, or along the y-axis. So what that kind of represents is, in this case, since this is the North Pole, this vector is 5 meters along the east direction. East is this one, so this is our east. So this vector, all of it is along the eastern direction. So this is the vector going in that direction. So this is what they mean. If they said 5 meters west, it would have meant that this vector is going towards the west. So it would have been going in that direction. If they said 5 meters south, the vector would have been going down because that's where the south is, straight down. Okay. Now, of seeing what that means, let's quickly look at the last one. The last one is the most common one and maybe the most tricky for some students. But once you understand what it is, it really becomes very easy to work with. But the last one, what they're saying is 6 meters in a direction, 60 degrees north of east. So here the language is north of east. Okay, so for this one, all you have to look at is when they say north of a certain pole, it's like when you're standing on the eastern pole, look towards the north pole, measure your angle as if you're going towards the north until when you make that specific angle. In this case, it's 60 degrees north of the east. So in other words, we are on the eastern pole, which is here. Then once we are on the eastern pole, we have to start moving until when we make 60 degrees towards the north. So we have to start going in that direction until when we make 60 degrees. In other words, the vector is going to be a vector like that. So the angle here is 60 degrees. If let's say the question said, let's change the color. If the question said, let's say 30 degrees, and let's say east of south, let's say this is how the question read. 30, let's say 30 degrees east of south. In this case, we're saying we're standing on the southern pole, and from the southern pole, we want to move 30 degrees towards the east. So from here, we want to move 30 degrees towards the south, towards the east, I mean. So from the south, 30 degrees towards the east. So let's say that is where we make our 30 degrees. So our vector becomes this one with the angle here as 30 degrees. Okay, so these are the common terms that they will use to give you the direction of the vector whenever they're using poles instead of the axis. But then the question says, use the y-axis to represent the northern pole or the north pole. So in other words, for the north pole, what we have is the y-axis. And for the east, what we have is the x-axis. This brings us back to the xy plane. So they just use the north, the poles to present the direction, but we should be able to still use those poles. The north pole will give us the positive y, the east will give us the positive x, and the others will follow suit. Okay, now that we understand how that works, let's quickly see how we can use that knowledge to work out this particular question. Okay, so let's quickly draw our axis. So first, I want to present these vectors on the xy plane. So that's the y, that's the x. So these are axes. Okay, so what is happening? The first one, the first vector is 4 meters southwest. So southwest, where is my southwest? So southwest, the south is along the negative y-axis. So this is where my south is. So this is southwest. So it is exactly midway between the south and the west. In other words, midway between the negative x-axis and the negative y-axis. So I expect this vector to be exactly midway, exactly here. So this is my vector, and the question is saying this vector is 4 meters. So they haven't given me the angle, but since it is exactly midway, this angle here is 45. So again, I always advise you guys to draw a table whenever you're breaking down the vectors into components. So I'll quickly make a table. Down here, I'll finish presenting all those vectors on the graph later on. So I'll make my table, identify the number of vectors they're dealing with, and then also fill out their components respectively. In this case, we have 3 vectors. So each vector, so I'm going to label them. The first one is going to be A, second one is going to be B, and the third one is going to be C. So what I have, this column, I'm going to have the X components. And then in this column, I'm going to have the Y components. And towards the end, we're going to have the resultant. Okay, so the question is saying find the first part. What are they saying? They want us to find the components of each displacement. So if we look at this vector that we've drawn here, this is the one we've labeled as vector A. So how do we get its components? Well, what we have to do is we observe the components that make this vector. So again, I want to enclose that angle. So this is going to be my horizontal, and then this is going to be my vertical. That makes my vector. So once I have this, I have a right angle triangle. This is A in the x-axis, and this is A in the y-axis. So by observation, you see that A in x is adjacent to the 45-degree angle. So from here, you should see that A in x is going to be given by cos, and A in y is going to be given by sine, since they are opposite to each other. I mean, A in y is opposite to the 45-degree angle. Now, one other key thing that you have to remember here is that A in x is pointing to the left. A in y is also pointing down, meaning that these 2 components are both going to be negative. In other words, perhaps I can even, let me create more room here. So for vector A, what we have, by observation, it is related to the angle by cos, and it is going to the left. So this is going to be negative. The vector itself, that is 4, and then cos, the angle is 45. So if we evaluate what this is going to give us negative 2.83. Okay, so I'm going to put everything here in meters and everything here as well in meters. So I don't have to write meters every time. Okay, so this is the x component of vector A. Now the y component, again, the y component is pointing down, so it's going to be negative. So again, it is opposite to my angle, so I'll use sine there. So it is the vector itself for sine the angle 45. So sine 45 and cos 45 are the same, or they are equal. So we expect this to also be negative 2.83. Okay, this is vector A. So once we obtain vector A, the next part is to get vector B. Now, where is B? So if we come back to our diagram here, or to our question, B is said to be 5 meters east. So B is from this point. Let me use a different color. Use that color. So from this point, we're going towards the east. This is the eastern line, or the eastern direction. So that is the direction of my vector B. And the value of B, 5 meters in that direction. So what this should show you is that B has no vertical component. The whole lot of B is along the horizontal, meaning that the y component of B is going to be 0. But all of it will go towards the horizontal. And since it is towards the positive x, the x component is going to be positive. So there was really no work for us here. If you wanted to use angles here, you would have had to observe that the angle between the vector itself and the x-axis is 0. So you'd have had to use the vector itself, 5 cos 0, which would have given you 5 as the x component, and 5 sine 0, which would have given you 0 as the y component. Okay, So that was quick for the vector B. The last one is for us now to get the vector, the components of the vector C. So again, for the vector C, we want to get the x and the y component of that vector. Okay, so how do we do that? Well, the first thing that we have to do is go back to the question, understand where this vector is. So the vector, vector C is 60 degrees north of east. The magnitude is 6 meters. So north of east, we are along the eastern line, which is this line. So from the eastern line, we want to measure 60 degrees. So we want to measure 60 degrees from the eastern line going towards the north. So from here, we have start going towards the north until we measure 60 degrees. So our vector becomes this vector, approximately that. So this is our 60 degrees. So now that we have our vector, this is our vector C. The magnitude is 6 meters. The next thing now is to get its components. So to get the components of this vector, okay, I think I can go back to green. Let me use red. Okay, to get the components, of course, the x component, I want to make a right angled triangle so that my angle is between. The x component is this one, horizontal up to that point. The y component is the vertical one, so that the angle, this angle here is 90 degrees, and that 60 degrees is inside the right angle triangle. So this is the y component of the vector C, and down here we have the x component of C. So what you should notice is the x component is along the horizontal, along the positive x-axis. So it is going to be positive. And apart from that, it is adjacent to my 60 degree angle. So the x component is adjacent to my 60 degree angle. So this is C in x. So C in x is adjacent to my 60 degree angle. Because of that, I'm going to use cos. So it is the vector itself cos the angle. So for C in x, I'm going to have the vector itself 6, then cos the angle 60 degrees. So if I evaluate this, this is going to give me cos 60 is half. So this is going to be half, then half by 3 by 6, I mean, is going to give me 3. Then next up, the y component of C. So the y component, when I come back to my diagram, the y component is opposite to my 60 degree angle. Because they are opposite, I'm going to use sine. So it is the vector itself, 6 sine the angle. So this is 6 sine the angle 60. So again, when you look at the y component, it is pointing up, implying that it is going to be positive. The x component was pointing to the right, meaning that it was going to be positive. So the y component is correctly positive, and when we evaluate this, we get 5.20. So doing this, we have obtained the components of each vector. So this answers part 1, getting the components of each vector. Now, the second part of this question, which is the components of the resultant. Now, to get the components of the resultant, all we have to do is to add the components of each vector according to according to the respective components or respective axes. So I will add the x components with the x components to get, or add respectively the x components to get the x component of the resultant, and I'll add the y components of each vector to get the y component of the resultant. Doing so, notice that now we're saying that if this is the resultant, its x component. To get its x component, we have to add a in x, the x component of a, plus the x component of b, plus the x component of c. So what we have here is the x component of a was negative 2.83 plus the x component of b, this was 5, plus the x component of c, that was 3. So adding these comes to give us a add them all, this comes to give us 5.17. So this is in meters. So I can get this value and fill it in my table. So this is the resultant. So this is 5.17. Okay, lastly now, the y component of the resultant. So just like we saw earlier, it's going to be the y component of B, the y component of A plus the y component of B plus the y component of C. So what we're going to have is, this is going to be negative 2.83 plus 0, the y component of B was 0, then plus the y component of C, that was 5.20. Adding these, we see that the y component, the y component of the resultant comes out as 2.37 meters. So from here, we can get this and fill it in our table. So that is 2.37. Okay, so now we've answered part 1 and part 2. Part 2 was only getting the components of the resultant, which we have now done. Now we can move on to part 3. Part 3, the magnitude and direction of the resultant. So to find the magnitude, what we have to do is we have to combine the components of the resultant using Pythagoras. You will see again why we're using Pythagoras when we make that sketch, the graphical representation in the last part. Okay. So the magnitude of the resultant, we get it by Pythagoras theorem, which is r in x squared plus r in y squared. So doing this, we see that all we're doing is the square root of 5.17 squared plus 2.37 squared. Okay, so evaluating the square root there, we see that our answer comes out as 5.69 meters. So this becomes the magnitude of the resultant. The last part is to get the direction of the resultant. To get the direction, we use tan. So this is going to be, the direction is equals to tan inverse. And then we have the y component, r in y over r in x. So this becomes tan inverse. And then r in y was 2.37, r in x was 5.17. So evaluating this, we see that the angle comes out as 24.63 degrees. Okay, now every time when you get a direction or the angle of a given vector, the best thing that you have to do is to present this vector on a graph to kind of try to understand how this angle or where this angle you have found is, which takes us to part 4. See, sometimes you have seen in the previous videos, what we've had to do after getting an angle like this is maybe to subtract it from 180, or maybe add it to 180, or subtract it from 360. How do you know whether you have to take another step for it to be the correct answer? Well, that leads us to the last part of our question. The last part is to present it on a graph, graphically present this vector or the resultant of this vector. So all we have to do is draw the xy plane. So this is just a sketch. So we have the x-axis and we have the y-axis. Now, what we want to do from there is we want to show where each component is. So the x component, it was positive. The thing here that we are interested in is whether each component was positive or it was negative. That is what will help us create an image of where this vector is. So the x component of the resultant was positive. It was positive 5.17. So we know to say it was in this direction. That was the x component. I'll say r in x. The y component was also positive. So the y component was positive, meaning it was going to go up. So this was the y component. Once we've done this, the resultant itself starts from the origin and up to where ry ends. So this is where the resultant is. The angle we found is this angle. Now, how do we know whether we have to take another step after making this sketch? Well, what we want to do is to present the angle as a direction. One, it has to be measured from the positive x. From the positive x. Apart from that, it has to be measured anti-clockwise. In this case, we see that our angle satisfies those two conditions. That 24.63 degrees that we have found. One, it is measured from the positive x. Two, it is measured anti-clockwise from the positive x, meaning that it actually qualifies. It is measured from the positive x and it is measured anti-clockwise. So that actually gives us the correct direction we want. So that answers part 4. Just to give you guys a heads up, if you realize that any of the components is negative, then you have to take another step. If the x component is the one that is negative, it means that, let's say the x component is negative, the y component is positive. It means that your vector, your angle, the angle that you found is here, meaning that you have to subtract it from 180. If let's say the y component is the one that is negative, the x component is positive, it means that the angle you have found is this side. In this case, you have to subtract that angle from 360 for you to get the angle that is anti-clockwise from the positive x. If both the x component and the y component are negative, the angle that you will find in this case using tan angles is going to be an angle in the third quadrant. It's going to be there. For you to give it as an angle or for you to state the direction, you have to add that angle to 180 degrees. In other words, if the x component is negative, the y component is positive, then what you're doing here is you are subtracting from 180, subtract your angle. If the y component is the one negative and the x component is positive, then to get the direction, you're subtracting your angle from 360 degrees. And lastly, if both are negative, then what you're doing here is you get your answer, you have to add your angle to 180 degrees. And of course, if both are positive, then whatever you have found is your exact answer. So you can use this to remember whether you have taken another step, but I really don't see the necessity of you having to memorize this when a simple sketch can actually show you what you have to do. Okay, that brings us to the end of this tutorial. In the next session, we're going to look at another simple question. You guys can look at it in advance. Okay, otherwise, this was your tutor. We'll see you guys in the next tutorial.